Good morning, students, and welcome to Tuesday's math lesson with Mrs. Berg. Today we are doing lesson 17, common multiples. So you're going to need your math notes today and a writing utensil, and any color highlighter will do. So grab those three items and let's get started. So the first activity is just a quick little notice and wonder, all right, which is exactly what it's called. They're giving us two numbers, and they're giving us all the multiples of that number. So the first one is the number 4, and in the second list, it's multiples of the number 6. Now remember, when I say multiples, think of your multiplication table. So multiples would be any two numbers multiplied. So think of your multiplication facts. So 4 times 1, 4 times 2, 4 times 3, 4 times 4. Any two numbers multiplied, in parentheses, multiplication facts. That's really the best way that I remember what multiple means. I just think of my fact families. So let's go ahead and circle all the multiples of the number 4. So you just kind of can say them. I'll say them out loud. You can say them mentally to yourself. So 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. And 4 times 6 is 24. And we're out of room. The next one is the number 6. So let's talk about our multiples of the number 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. And 6 times 4 is 24. And we're out of numbers. This is why we started out 6th grade. Remember, guys, doing all of that multiplication review with our facts families, because as you get into the higher grade levels, it's supposed to be just they're all memorized and it's quick and easy and you're very fluent in your mathematical multiplication fact families. So what do you notice? What do you wonder? Well, I guess I noticed that we had a lot more multiples of 4 than we had of 6. We had 1, 2, 3, 4, 5, 6 multiples of 4, but only 1, 2, 3, 4 multiples of 6. Something else I noticed that these two numbers, 4 and 6, actually share some multiples. Okay, they both had 12s, excuse me, and they both had 24. Okay, so these would be called common multiples. When two separate numbers share multiples, is called a common multiple. So 12 and 24. Just speaking out loud, just to get us warmed up. So I'm actually going to have a skip 7.2 for now. We will do it, we'll come back to it, but I want to jump forward to 7.3 because this should be some basic review for you guys from 5th grade. All right, we're just finding the least common multiple. Now the numbers they gave us were 6 and 8. And the least common multiple was 24. Well, how did they get that number? Let's do a quick review. All right, so the first thing we have to do is find all the multiples of 6 and all the multiples of 8. Couple ways you can do it. You can put them in a list or you can put them in a table. All right, so if we did a table, just so you could see what a table looks like, it would look like this. We'd say 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18. 4 times 6 is 24. And we'll stop at 5. 5 times 6 is 30. Let's do the same thing for the number 8. Again, we're making a multiple list. So 1 times 8 is 8. 2 times 8 is 16. 3 times 8 is 24. 4 times 8 is 32. And 5 times 8 is 40. I can stop there because I'm looking for the least common multiple, which is 24. And I noticed, okay, here's 24 and here's 24. So if I look at all of the multiples they share, the first one that they share is the number 24. I'm sure if I continued these tables, we'd come up with more, but we just wanted to find the least common one, so the smallest one. So 24, and I can stop. So that's how they came up with that number as a review. Let's turn your page. The question is asking us, what do you think the term least common multiple means? And we can simply say, sometimes you're familiar with this, it's called the LCM, least common multiple. And we can define it by saying the smallest multiple that two or more numbers share. And that's the definition of a least common multiple. Question 2 says, find all the multiples of 10 and 8 that are less than 100. And then come back and find the least common multiple of 10 and 8. So this time on, I'm going to show you, I showed you the table before, but this time I want to show you another method, which is called making a list. Okay, this is really nice when you have small numbers and you have to find all their multiples. So we'll start with the number 10 because that's pretty easy. All right. And we just think of the multiples of 10. So 10 times 2 is 20, 10 times 3 is 30, 10 times 4 is 40, 10 times 5 is 50, 10 times 6 is 60, 10 times 7 is 70, 10 times 8 is 80, 10 times 9 is 90, and 10 times 10 is 100. And I can stop because I'm going to find less than 100, so I don't have to go any farther than 100. Now let's come over here and make a list for the multiples of 8. And we're going to be counting by 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. 8 times 6 is 48. 8 times 7 is 56. 8 times 8 is 64. 8 times 9 is 72. 8 times 10 is 80. 8 times 11 is 88. And 8 times 12 is 96. And I can stop there because the next number would push me over. So do you guys see what I was doing there? Did you notice how it was good that I was very fluent in my multiplication facts? Otherwise, man, that would have been very difficult. So now I have my list of 10 multiples, my list of 8 multiples. I want to see which ones do they have in common. So I'm just going to kind of start to look, and I notice that right here, the first one I come to is they both have a 40, and I'm going to keep going to see if there's any others. And I see that they share an 80. I'm just going to kind of circle. And that's it. So they have two common multiples, 40 and 80, but the least common multiple, so the common multiples are 40 and 80, but the least common multiple, my LCM, is 40. Let's try another practice. Find all the multiples of 7 and 9 that are less than 100. Again, 7 and 9 are kind of small numbers. I'm going to go ahead and make the list because I'm just having to find the least common multiple. They're not having me do anything else. So there's my 7, there's my 9. Okay, so now we're going to do 7s. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. 7 times 6 is 42. 7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 63. 7 times 10 is 70. 7 times 11 is 77. 7 times 12 is 84. 7 times 13 is 91, and 7 times 14 is 98. Those last two you probably didn't know, but you should have known all the way up to 84. And again, we can stop when we get as close to 100 before going over. Let's do 9. 9 will get there a little bit quicker because 9 is a larger number than 7. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. 9 times 6 is 54. 9 times 7 is 63. 9 times 8 is 72. 9 times 9 is 81. 9 times 10 is 90. And 9 times 11 is 99, and I'm going to stop there. Now I have all my multiples of 7 and 9. Let's see what the common one and the least common ones are. I'm just going to start looking to find, okay, and I see right here, I see a 63 in each of them. That would be the least common multiple. Let's see if there's any others. So up to this point, there may be more if we were to keep going, but we're stopping. So this time, we have a least common multiple of 63. Okay? And you can cross off all you ready for more. All right, and I think I'm going to have us, let me just double check here, go back to, yes, let's go ahead. So that is just finding common multiples and least common multiples. Again, you can do the list method. If you have a lot, if you just have to do a couple, like this one down here, you can do a table. Let's come back now to 17.2. Now 17.2 is a story problem. So in this situation, it's going to benefit us to actually use a table, and you'll understand why once we get further into the problem. It says a florist can order roses in bunches. Okay, so she's a bunch of 12, that's for the roses, so a whole bunch of 12 roses. And then she can order a bunch of lilies, and she gets 8 lilies in a bunch. So we have 12 roses in a bunch and 8 lilies in a bunch. Last month she ordered the same number of roses and lilies. If she ordered no more than 100, okay, so this tells us we don't have to go past 100, of each kind of flower, how many bunches could she have of each type of flower? So yes, we have to find the least common multiple, but then we have to take it one more step further, which is why I'm recommending we do the table. So they don't really give us a ton of room here, and I didn't want to try to cram it all in here. So I'm going to grab a lined piece of paper, and I kind of suggest you do the same, just so we have plenty of room without cramming it in. So here's my lined piece of paper. And this is 17.2. Okay. And the first thing we're going to do is we're going to find the common multiples of 12 and 8. So that's step 1. This is kind of like a 2-step problem. So here's my 12. And I'm going to do a table. And you'll understand why I'm doing a table with this type of a story problem instead of just making a list. All right. So here's my table. Now let's start doing the multiples of 12, okay? So 1 and 12. 2 times 12 is 24. So I'm kind of going like 1 times 12 is 12. 2 times 12 is 24. 3 times 12 is 36. 4 times 12 is 48. 5 times 12 is 60. 6 times 12 is 72. 7 times 12 is 84, and 8 times 12 is 96. And I can stop here because, again, I don't want to go over 100. So I can go as far as 8. So I have 1 bunch, I have 12 flowers. 2 bunches, I'd have 24 roses. 3 bunches, I'd have 36. And again, these are the roses. So maybe I should write roses up on top. The next one, this is going to represent the lilies. So for the lilies, I can only get 8 roses in a bunch. So 1 bunch, 1 times 8, gives me 8 lilies. 2 bunches gives me 16 lilies. 3 bunches, 3 times 8, gives me 24 lilies now. If I buy 4 bunches, 4 times 8, I have 32 lilies. If I buy 5 bunches times 8, I have 40 lilies. 6 bunches, 6 times 8 is 48. 7 bunches, 7 times 8 is 56. 8 bunches, 8 times 8 is 64. And I'm going to keep going because I can go as close to 100 as I can get. 9 times 8 is 72 bunches. 10 times 8 is 80. 11 bunches, I have 88 lilies, and if I have 12 bunches, I have 96. So definitely going to stop there. So you can see that I can have a lot more bunches of lilies because I only get 8 in a bunch before I have to stop. All right, so that is part 1 of the problem. Now it says we found all the combinations. What is the smallest number of bunches of roses she could have ordered? Okay, first we actually have to find the combinations. So this is what it means when it talks about finding combinations. Let's circle the common multiples of 12 and 8 in our tables. So I'm just going to kind of look down the right side of the table and stop as soon as I find a common multiple. So 24 was the first one. I'm going to continue going, stop, to 48, and 48 was another one. Continue going, stop, 72, and 72. Continue going, 96, and 96. So I had 1, 2, 3, 4 common multiples. So there's 4 times, okay, then I can have the flowers where they're all going to match up. So that's what it's talking about when it says find all possible combinations. So let's find the first combination. So right here, I'm just going to kind of draw like a connecting line, all right? And what this is telling me is I have 2 bunches of roses and 3 bunches of lilies. So here's one combination that the florist can do. And I have another combination because I have a common multiple of 48. So then my second possible combination is 4 bunches of roses and draw the line 6 bunches of lilies. Okay, this is why I made the tables, because then you can easily see your answers. We have a third possible combination. Sorry guys, I ran out of battery, so I'm not sure where I left off in the lesson, but we are finishing up this one problem here. And the very last common multiple was the 96 they shared, which means that we could have 8 bunches of roses and 12 bunches of lilies. So there are 4 choices that we could make with the lilies and the roses. The last question simply said, what is the smallest number of bunches of roses she could have ordered and the smallest bunches of lilies? So really, we actually already found that. It was this very first one here, the least common. It was when she had 24 bunches of roses and 30 bunches of lilies. And if you look back up here, it was right here. That would be our least common multiple. All right, so total of 24 flowers of each, and that would be your answer, okay, for number 2. So we kind of did all this. In fact, I'm just going to say see lined paper, because we did all of our work on a lined paper, right? The very last problem in today's math lesson is kind of similar to what we were just doing with the lilies. Just another example, okay, of a problem you could have. It's called Grand Prizes on Opening Day. Lynn's uncle is opening up a bakery. On the bakery's grand day, he plans to give away prizes to the first 50 customers. Okay, so we only have to worry about getting up to 50. Every 5th customer gets a free bagel. Every 9th customer gets a free blueberry muffin. And every 12th customer gets a slice of carrot cake. So giving away lots of good food here. So Diego is waiting in line, and Diego's the 23rd customer. He thinks that he should get farther back in line in order to get a prize. Is he right? If so, how far back should he go to get at least one prize? All right, so this is a great example of a least common multiple problem. So we've got 3 different prizes that we're giving here. The first one is a bagel. So I'm going to just label that B for bagel. And every 5th customer will get a free bagel. So that means customer number 5. And then 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. Then we have 35, 40, 45, and I'm going to stop at 50 because I only need to go to 50. That's what the problem said. Every 9th customer gets a blueberry muffin. So M will be the muffins, and that's every 9th customer. So let's find all the multiples of 9. So 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. And 9 times 5 is 45. And I'm going to stop there because 9 times 6 would be 54, and I only have 50. And the last one, every 12th customer gets a carrot cake. So C will be our carrot cake, and that's every 12 customers. So I'm not going to have that many because, again, I can't go past 50. So I have 1 times 12 is 12. 2 times 12 is 24. 3 times 12 is 36. And 4 times 12 is 48. And I'm going to stop there because 5 times 12 is 60, and that's over. So here's all my multiples. So what I've got to do is try and find some common multiples between these 3 numbers. So I'll start with the bagel and the muffin. I'm looking. Okay, and I see that they each have a 45. Then let's see if there's any other common. There's no common multiples between the carrot cake and the blueberry muffin. And the bagel, but there is a common multiple of 36 between the carrot cake and the muffin. So no customer is going to be able to get all 3 because there isn't a multiple that all 3 share. But a couple of customers could get a bagel and a muffin, and some could even get a muffin and a carrot cake. So it says here, Diego is the 23rd customer in line. All right, so if he's in the carrot cake, he would be right here. So he so far couldn't get anything. He'd have to go all the way over, okay, to this 36 before he'd get a slice of carrot cake. So he definitely would want to get farther back in line if he went to carrot cake. Now let's see here. If he's 23, again, he'd have to kind of get farther back in line before he could get a muffin. And if he is 23, he'd be right here. It says that the 5th customer would get a bagel, so he's not couple people in front of the 25. So he would definitely want to move back so he could get one of the items. So how far should he go back? Well, I'd say at least go back a couple places so he could get the bagel. And that has to do with Diego. Let's look at Jada. Jada is the 36th customer. Okay, so Jada, oh, well, look at Jada. She's lucky because right here, I see there's a common multiple. So Jada can get a muffin. So she can get a muffin. And she could also get a carrot cake and carrot cake. Is it possible for her to get more than one prize? How do you know? Well, we just said that. Yes, it is. It's possible because BC 36 is a multiple of 9 and of 12. So she can get both. Last one, number 3. How many prizes in total will Lynn's uncle give away? Well, let's see. Let's just count them up here. So for the bagels, he's going to give away 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in bagels, he's giving 10 away. In the muffin, 1, 2, 3, 4, 5, he's giving 5 muffins away. And the carrot cake, he's giving 1, 2, 3, 4 carrot cakes away. So if we add those up together, you get 19 prizes. So that is how many prizes he's going to give away. All right. So that is the lesson today, which means it is your homework time. Okay. You were going to pause this video. You're going to do your 5. There's only 5 practice problems today, and I have loaded the PDF in Google Classroom. You're going to come back and check your answers on the video. Okay, so you have 1, and then you have 1 Khan Academy video to watch. Remember, we always watch the videos first, guys, and then 1 Khan Academy assignment. So the homework practice problems, you're actually just on your honor. I mean, obviously, we're not meeting again, so I'm not going to be able to check your homework. But doing your homework will let you be successful with the Khan Academy and then the upcoming quizzes and tests. So please don't forget to do your homework. There's only 5 problems tonight. All right, so pause the video. We'll be right back. Okay, welcome back for your homework. Okay, let's see how well you guys did on your homework real quick. All right, time to check it. Question A says a green light blinks every 4 seconds and a yellow light blinks every 5 seconds. When will both lights blink at the same time? Okay, this means it's a least common multiple problem. So we want to find the LCM between 4 and 5. So let's make a multiple list because they're little numbers of 4 and 5. And I usually tell my students, go out to multiply by 6 and see if you can find anything. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, and 4 times 6 is 24. And stop there and see if we get lucky. 5s are very easy. You've got 5, 10, 15, 20, 25, and 30, and then we're stopping to see if we have a common multiple. And I noticed that we do in fact have a common multiple, which is 20. That means at the 22nd point, they're both going to be blinking at the same time. B, a red light blinks every 12 seconds, a blue light blinks every 9 seconds. When will they blink together? Another least common multiple problem. This time we have 12 and we have 9. Let's go up to the first 5. So we have 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4, no, I'm sorry, 12 times 4 is 36, 12 times 5 is 45, and 12 times 6 is 72. 1, 2, 3, 4, wait, 1, 2, 3, oh, what did I forget here? Number 9, we have 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, and I can stop there because I found the least common multiple, which is 36. 36. 1, 2, 3, 4. Oh, I forgot 5. No wonder I was going crazy up here. It's 60. We'll squeeze a little 60 in there. Doesn't really matter because we were finding least common multiple. Explain how to determine when 2 lights blink together. Well, basically, anytime there's a common multiple, any common multiple tells you they're blinking together. So the first time is 36, but they'll blink again at 45. And I'm sure if we did this, they'd be blinking again in the first problem. Number 2, list all the multiples of 10 up to 100. So you're just simply counting by tens, right? So we have 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Now we're going to list all the multiples of 15 up to 100. 15, 30, 45, 60, and 90, and I'm going to stop. Are there any common multiples? Oh, what is the least common multiple? So I'm looking, and the first they have in common is a 30, so the LCM is 30. Hopefully you got that one. Now the next 3 problems, one more, and then we have some review problems. Cups are sold in packages of 8. Napkins are sold in packages of 12. Okay, what is the fewest number of packages of cups and the fewest number of packages of napkins that can be purchased, so there will be the same number of cups and napkins? Okay, so this kind of reminds me of like doing a chart. So I'm going to go ahead and put my answer on a piece of paper so I have a little bit more room, because the first thing I have to do is make a chart for the 8 cups. So I'm going to put this, cups. So we have 1 and 8, 2 and 16, 3 and 24, 4 and 32, 5 and 40, and 1 more to get to 6, 48. And then I have napkins. And there's 12. They're sold in sets of 12. And we can stop at 6. So we have 1 and 12, 2 and 24, 3 and 27, 4 and 36, 5 and 45, and not 45. Oh, this is 12. Oh my goodness, I'm going crazy here, guys. I'm sorry. I was thinking it was 9. 3 times 12 is 36. 12 times 4 is 48. 12 times 5 is 60. And 12 times 6 is 72. Sorry about that, guys. So I want to find the fewest number of packages of cups. So let's see where they start to share their first. And I see right here, they share a 24. They also share a 48. Okay, so there's 2 times when they would have the same, but they're asking for the fewest number of packages in cups. So if I look at my 24 here, what this tells me is I have 3 packages of cups. So 3 packages of cups. And I have 2 packages of napkins. Therefore, I have a set of 24. So I have 24 sets. 24 sets. That answer kind of answers both A and B at the same time. 4 and 5 are quick little review problems. One is the coordinate plane. It says a rectangle can be drawn on a coordinate plane. So let's quickly plot these points. I have -6, 1, 2, 3, 4, 5, 6, up 9. So I'm way up here. And I have 1, 2, 3, 4, 5, and 9. And I'm making a rectangle. So as long as my points line up where I can connect them to form a rectangle, I can put the points up here, I could bring the points down here, as long as I'm forming a rectangle. So what could these be? Well, I still came over -6, so maybe this is D, this is A, this was B, this is C. So for C, I came over 5, and maybe I only went up 2. So 5 and 2. And then for point D, I moved over -6, and I only came up 2. You could have put different points on there. That was just an example that I was using. Last but not least, number 5. A school wants to raise $2,500 to support its music program. If it has met 20% of its goals so far, how much money is raised? Well, we're simply finding out what is 20% of 2,500. So we did these a long time ago. You simply convert that 20% to a decimal. So 20% becomes 0.2. Of becomes multiplication. 2,500. 0.2 times 2,500. Hopefully you got the answer of $500. B, what if it raises 175% of its goal? How much money will the program receive? Well, same type of method. We're finding out what is 175% of 2,500. We change this to a decimal by dropping the percent, moving the point 1, 2 places to the left. Remember that? So now it's 1.75. The word of becomes a multiplication symbol, 2,500. And 1.75 times 2,500 is $4,375. Okay? All right, that's today's math lesson. Don't forget the Khan Academy video and the Khan Academy for homework. Thanks, guys. Have a great day. Bye.